flexibility of topologies and other things like that. So let me start the presentation. A bit about me for those of us who were not there yesterday. I'm Rohit Yadav. I'm from Gurgaon, India. I had a joke yesterday, which I'll try to repeat again. I'm one of the oldest, ancient people in the community by number of years. 7 years in the so the joke was I'm a 7-year-old dinosaur in the community. The only change since last 7 years is dinosaur has grown bigger, grown a mustache, lost some hair. Some of the hair has grown grey, and I love cats, and these are my 2 cats. Bit about me. So what I want to do in this talk is just give a survey and review of the current implementation of the virtual router, maybe the network subsystem within CloudStack, and then talk about some work I had done over the last 1.5 years around reducing the downtime, because my kind of interaction with virtual router started with my work around systemvm templates, then some project on reducing the downtime when you upgrade virtual routers, let's say after upgrading CloudStack. And now what I want to do with this talk is propose some ideas, keep it interactive. So if you have anything to share, ask questions or discuss, let's do that. And then maybe discuss some ideas around how can we address the technical debt, how can we refactor the code base, some of the things maybe Anurag mentioned, and look at some complex use cases and how those ideas can solve such complex use cases. So the current virtual router is based on a systemvm template. So this is true for 4.11 to 4.13 at least. It's a Debian 9 based operating system, uses Linux 4.9. We have a fixed kind of root disk size of 2 gigs. It uses Java runtime 1.8 version, so it's kind of pre-installed. And it has tons of packages which are pre-installed. And the way we program the systemvm template, we can program it using a couple of methodologies. We use a patching. So initial patching is done by passing a string we call a command line through various ways. So different hypervisors, we use different ways to pass this command line. And then we use a static systemvm.iso file, which may have some payload scripts, jar files and things like that to patch that systemvm template. And that, depending on the command line and the systemvm.iso, these 2 payloads, we can graduate or patch a systemvm template to become either of SSVM, CPVMs, or different kinds of VRs, like your redundant VR, your shared network VR, or your isolated network, your VPC-based VR, and things like that. Couple of issues that I would personally point out is around upgrade, around HA and redundancies, and the whole mechanism that we have right now that programs the virtual router. It's kind of fragmented. There are different scripts. There's no consistency. It's hard to maintain, debug, test, and whatnot. Excuse me. If you look at this diagram, it basically tries to display like how we do patch the systemvms. So we start with a template, which is a Debian-based systemvm template, basically a disk. We have some script that starts every time the OS boots up. The script will try and read this command line file based on different hypervisors. So the script will try to detect whether it is on KVM, VMware, or Zen server. Based on that, there are different mechanisms. For example, in case of KVM, right now we pass the command line parameter using a serial VirtIO device which is attached to the virtual machine, and inside of the VR we have a KMU guest agent which we use to basically pass and write this file to a static location, and we basically hope that the cloud early config file, which is sort of the cloud init-ish kind of hackish script we have, will try to read this command line. It will detect a systemvm.iso file, mount it. Within the ISO file, you can see there are some payload. There's a tarball. Sometimes there's a SSH authorized key file, so that management server can SSH to the VR directly or indirectly through the hypervisor host. And we have an agent.zip file, which has a bunch of jars to run the SSVM or CPVM agent. Then, depending on the type of systemvm template or systemvm appliance we have created, we have bunch of scripts which will basically create a VR or a SSVM or a CPVM or something else. Once we have that ready, then CloudStack will basically poll and check whether are we able to SSH into the VR. So it will do that multiple times. Once we are able to SSH into that appliance, then the further programming does continue. So my journey kind of started with this question: can we reduce? So one of the issues I was trying to personally address is when you are upgrading a version of CloudStack, the main pain point for a lot of users were, especially in case of large environments where you have, like, say, 16,000 VRs, it can take hours to actually upgrade. And an incorrect upgrade or a faulty upgrade would mean downtime for the users of that network, of whatever kind of network that is. That means downtime of services in case of shared networks, for example, and complete downtime of networking in case of isolated network, VPC networks and whatnot. So the idea was, can we make upgrades more reliable, and also can we make them as low as possible? So this is a slide from the previous talk where what we did was something, if you ask me, it's kind of silly and it's not very intelligent. So the approach was very simple. In the previous versions of CloudStack, when you upgraded your routers, what we did was, after the upgrade path would change the systemvm template to the new one, we would simply destroy the old router and then create the new router. Wait for it to come up, then program. The issues with this approach is, when you destroy the old router, your perfectly running router is gone. And then when you try to start a new one, there are steps involved to provision that. That means first you will copy the disk. Then if that is successful, then you'll try and start that VM on a host. If that is successful, then you'll try to hope that patching works and there are no bugs in that. Then you'll SSH and do a lot of these things. If you look at VMware, for example, without this sort of zero downtime upgrade thing, a typical test environment took like 2 minutes. In a large scale environment, it would be even bigger because of noisy neighbors and other issues. So the general idea we implemented was, let's not destroy the old router. Instead, let's first deploy a new router. If there are any issues with deploying the new router, you fail early and you get rid of that new one. So your old VR is still running and your networking, all the services are still running. Now the thing is, virtual routers are kind of stateless. So if you have multiple of them connecting to the same guest network NICs, and you may have confusion created for guest VMs, but packets will not be lost. So the idea is very simple. You deploy a new VR, program it. If it works, then you destroy the old one and you reprogram it. By reprogramming, what I mean is the new VR will simply do a broadcast. So like all the entities in that network connected to the bridges, whatnot, they are aware that, okay, a router has changed. And the issue is that ARP can have a caching issue, which can typically be up to 30 seconds. So if you look at the second column of the table, you see they are around 30 seconds. So like 30 seconds is the max downtime you can have. In the ideal case, I actually observed in sometimes, let's say, if your old and new VR on the same host, when the new VR is deployed, it will be like plugged into this existing bridge. So in such cases, I actually observed in some cases like there was 0 seconds downtime. So this is okay. I mean, it's a quick win, and it's available in 4.11 to 4.13 and whatnot. But and this is the slide to kind of explain what I've explained to you already. But the question still is, can we still make it zero? Because even with this approach, it still fixes a lot of operational issues, and downtime is definitely reduced, and you fail fast early. So instead of destroying the old one, you first try and create a new one. If there is a problem with that, you catch the problem early, and you can still have a more reconcilable or fixable problem at hand. So the problem is still, can we still make it zero? So let's look at what happens during systemvm upgrade. So the first thing we do is, prior to the upgrade, so before even you're upgrading your CloudStack, you have to first register a template. with a specific name as per the release upgrade documentation. And then when you do upgrade, what the upgrade path will do, which is a database class, which will simply see whether a template by a given name is available or not. It will change some things in the database, simply enable that template to be of type system. And during upgrade, a new systemvm.iso file will be created, replacing the old one, which will have sort of the new patching code. And the rolling restart, the thing that I described, you create a new one, program it, destroy the old one. So rolling restart will kind of replace the old VRs with the new one eventually. So the problem still is that it's in case an admin forgets to register the template after upgrade, you have to roll back, or you have to fix the template manually. So those are like couple of issues around upgrade. Now let me talk about when is a systemvm template upgrade necessary. So if you look at the recent releases like 4.11.2, 4.11.3 and 4.13. So between 4.11.3 and 4.13, there is no systemvm template change. So if you are already on 4.11.3 and you upgrade to the latest 4.13, which should be out after the documentation work in couple of days and weeks, there's no need of a new systemvm template. Why? Because there are no changes in the packages. The systemvm template basically has a bunch of scripts, tools, the Java runtime environment, some packages like your Apache web server, HA proxy, IP route tools, and all of those things. And they don't, we as a project, when we move to a different version, when such changes are not necessary, there's no security issue that require new packages to be installed in the template. In those cases, the template is not necessary. And the last thing is if there is a fundamental change in the patching process itself. For example, in 4.11, we had to, there were some issues around making the patching work on KMU EV. So we had to move from an earlier, much barebone way of talking to the serial port, and then we moved to KMU guest agent based approach. We had to install a new template because we wanted to use the KMU guest agent. So those are places like situations where a systemvm template is necessary. Let me actually now talk about how we program virtual routers, to try to give you an end-to-end perspective. So as a developer, I start with a feature or a bug or an improvement, and I have to first create a systemvm template. So I need to build that new template, get it tested, get it reviewed. We go through the voting and testing cycle. Once that is done, it is being hosted on a community server, a community hosted server like downloads.cloudstack.org or something like that. And then once those things are done, as a user, you would install the systemvm template. CloudStack will will work with the hypervisor and try to set up the networking. And in terms of programming, if you see on the right hand side, we are programming. What I've done is I've listed down various features which are now provided by the virtual router. Very basic things like DHCP and DNS mask. And in brackets, you can see name of the sort of providing services. Like what is the thing that kind of drives that feature. Like DHCP and DNS are provided by the DNS mask service in the virtual router. I'll pick a random one like static routes, firewalls, and all of those things are implemented by IP route 2 tools. And then we have some specific CloudStack specific features which are for just ongoing monitoring and whatnot, like health monitoring and network statistics. So those are different scripts that do implement that specific feature. Now, this is just like what is the feature and how that is implemented. The more, I think, challenging thing is to explain how the current VR is being programmed. I don't want you to go and read this, because the point of this slide is to simply explain and make a point that it is complex. It is hard to extend. It is hard for a new engineer to learn something and implement something very quick. Long story short, what happens is there is no standard way of patching. There is no standard way of communicating to the VR from the management server. In case of VMware, you can talk directly. In case of Zen server and KVM, you have to go through the hypervisor host. And for each and every feature, there are different ways you have to SSH and execute a script with some custom paths So there is no standardization of interface. There is no standardization of how do you build, test, maintain, manage, administrate, upgrade, all of these things. And then the code is kind of fragmented. It's hard to actually read the code and make sense out of that. You cannot attach a debugging point. It's hard to go through the logs. So there are tons of issues around this. Now, what I want to focus on is we are still thinking about what causes downtime, right? So the question still remains, can we make the downtime zero? So let's first think about what are the core services in CloudStack Virtual Router versus non-core. So what I mean by core is that if you kill those services, like things like firewall, NAT, these are all provided by your Linux kernel. If your kernel kind of crashes, your networking, connectivity, everything kind of goes down. But let's say if your password server doesn't work, your metadata server doesn't work, HA proxy could be in that gray area, just like VPN. So those non-core services, if they have a slight downtime of, let's say, up to few seconds to a minute, it doesn't actually cause a huge issue. If a kernel crashes, there's connectivity, the services that are going to be down. If DNS mask crashes, then maybe the new VMs that are being started or existing ones which are requesting for like a renewal may be affected, but it's not that critical. So that's sort of the point of core versus non-core services. Let's also quickly look into recovery times. Let's say if there is an issue or a fault or a failure, how much time it typically takes to recover. So when you have an operating system service, they are typically fast enough. So this is with respect to the virtual router. Maybe Java processes could be slow because they take time to load, but typically most of the services, they are fast enough to kind of load or restart or recover. The operating system itself, if it crashes, can take a few minutes. If a virtual machine can crashed or failed for some reason because of faulty storage or a faulty host and things like that, it can be tricky and it can take a couple of seconds to a couple of minutes. And if your host has an issue, your entire infrastructure, a cluster is gone, a zone is affected, the data center specific network infrastructure is gone, that can take minutes to hours and I don't know, maybe even days, depending on what that issue is. So the point of all of this is to answer the question, can we have zero downtime upgrades at all? And the answer is actually yes, but maybe no. So it kind of depends on other things. For example, if you use redundant virtual routers with CloudStack right now, upgrade is actually zero downtime because we have a rolling scheme where we always ensure that there's one VR which is always up. But there could be another answer to this, which is a lot of people, a lot of our customers and users I've interacted with over list and whatnot. Many of them are very risk averse and they don't want to upgrade at all because they don't want to get rid of the virtual routers. And some of them may as part of the upgrade process haven't touched, let's say, or they take some time to agree let's say an upgrade maintenance window with the customer, with their own customers, with SLAs and whatnot, so that they know when they are going to be affected. And I think one of the answers could be don't destroy the VR. So that means the best way to ensure that there's no downtime is to not touch the VR. But that's fine. But how do we still upgrade? Because is there a way to get all of this? So let's discuss some ideas around this. So I think the first idea I would say is let's get rid of the systemvm.iso file. Let's think aloud what systemvm.iso file is. Systemvm.iso file is basically a small payload of scripts, packages, software, jars, and whatnot that need to be installed in the VR. I mean, doing this through the ISO is one way. Can we think of some other ways to do this? And the other thing is, can we reduce the footprint of the systemvm template, which will come in a slide shortly. The other issue I think with systemvm.iso file is it's kind of non-standard. Why? Let's think about the software upgrade and delivery schedule. For example, in case of KVM, this is delivered by the CloudStack common package. So an admin has to make sure that CloudStack agent and CloudStack common packages are upgraded across. Let's say if you have 10,000 hosts, you have to do this on all those hosts. Now, I'm not saying that's not possible. I'm saying people have automation for that. But but that still is an additional step you have to ensure and you have to verify as part of your upgrade process. In case of VMware, this is done through secondary storage. That means just having this approach requires dependency of secondary storage. If somebody doesn't want to use secondary storage, they have to, because systemvm.iso is hosted on the secondary storage. And in case of Zen server, what CloudStack does is, as part of the upgrade, it will copy the ISO file to each and every host at a specific location. So the point is that there are multiple sources of truth. And the solution right now is automation. So you have written scripts to make sure that as part of your upgrade process, all those things are at their correct place. And we have a non-standard patching process. So we have our own script which will mount, will check, and it's kind of brittle. If there are issues, the template is not at the correct position, or for some reason it's the ISO file is not at the current path. The other issue I would emphasize is, as developers, when we build, test, and run CloudStack, let's say a lot of the code actually gets triggered when there is a change in the version of CloudStack. For example, if you're working with VMware as a developer and you have made some changes to the systemvm.iso file, it will not copy itself to the secondary storage because there's no change, like fundamental change in the base version of CloudStack. So as a developer, you have to sometimes manually copy the ISO file to KVM host or VMware or Zen server, and you have to keep those things in mind. And overall, I should also mention that we have a dependency. We kind of assume that systemvm template will have a Java runtime environment installed. If there is a security bug in Java runtime environment, then you have to create a new template. You have to do upgrade for all the routers across your hardware. You have to do security advisory. There's a lot of process that is required when that happens. So the proposal or idea could be, can we think of ways of getting rid of this ISO file? At the same time, can we also think of reducing the impact layer in the systemvm template? That means reducing software which is pre-installed in the template. Like, don't install Java runtime environment. You can explore using Java 11's JLink that allows you to bundle a custom runtime environment with your application specific code. That means you're kind of building a package which has the runtime environment and the agent jars pre-installed. And the last thing is, how can we actually do this is, can we have a live patching mechanism? That means, right now it's kind of static, right? You have to reboot and the scripts will patch only at the time of boot. Can we have some sort of an API like live patch this? That means system is up and running, you simply go and patch the payload, patch the packages, the scripts and whatnot, maybe restart some services. So those could be some ways we can explore and try and solve this problem. And let me talk about another thing, but before I proceed, anyone has any questions, anything to ask or discuss? All right. So the next idea is, how can we get rid of the VR code base? I think we have heard a couple of complaints here that it's non-standard way in order to get from the management server to the virtual router with respect to VR programming. It's different for different hypervisors. It's difficult to debug sometimes. You have to go from management server to the host to the VR sometimes. And I think what I would like to propose is to first understand what is the code base right now. It's mostly Python and shell script based. It's custom, non-standard. The input outputs of all those scripts are different. So you have to actually read and understand what that script does if you want to extend, maintain or do something with an existing feature. And it's hard to unit test. You cannot test the VR code base or the virtual router in isolation. You have to have like the entire CloudStack environment up and running, and then use Marvin to kind of kick tests in tandem with CloudStack. So VR currently has no kind of place in isolation. It works only with management server. And as I mentioned, maintenance and extension issues are there. The code is fragmented. When you do upgrade, let's say as developers, now this is an issue from developers. When you're working on a VR related feature, you have to kill these CPVM and SSVM multiple times. I think if you remember Vay's talk from yesterday, remember what he did. He changed some global settings added like a SSL certificate, then he had to actually kill and destroy those CPVMs to get those changes applied. That's a routine we have. Anything to do with certain global settings or features or adding a certificate, you have to destroy the old thing. There's no way to live patch those. So that is fine, but can we introduce versioning of the tools and scripts? Because as a developer, when I'm working and changing things live, I cannot kind of do a hot reload of the code. If you catch my drift, you cannot do sort of a hot reload of the code or hot patching based on CloudStack automatically detecting changes in file based on checksums, SHAs, and things like that. And the last thing is, it's all manually executed by management server via SSH. So right now, what we do is some people have shared their complaints that if there are 10,000 IP table rules or 10,000 different things you want to configure to the VR, they are done, I think, sequentially in some cases. We have actually made improvements, so we do aggregate a lot of those commands. But overall, if you want to, let's say, program all the IP table rules, static routes, VPN, all those things are bashed by their let's say application or utility type, but not as a whole. And the way we do program virtual router, it's totally weird. When you're upgrading a virtual router, it kind of creates a specific XML file which has JSON in it, with some another JSON with some XML separator. So as a new person, I've had experience with looking into how new people kind of perceive those code, and you can imagine their the sort of confusion and pain that this code base would cause to them. So here's the idea. How do we implement live patch? So what I'm proposing is, let's have a small virtual router agent that is like a server. So we are kind of saying, let's, instead of SSH, introduce a server that can use the CloudStack CA framework. So it's like everything is still secure, authenticated, but you're not using SSL, the wildcard general SSH public key to SSH. So when you have virtual router specific certificate, for what it is for and for what IPs and whatnot, and that can be more secure, I think. The other thing is why I thought about VR agent. Why? Because this is something you can actually try on your laptops. Open a Python, try to write a Python script which will simply print hello world, sleep indefinitely, try to run, and you'll see it will consume anywhere from 6 to 30 MBs memory, because the Python runtime environment will consume that amount of memory. So in a resource constrained environment like virtual router, you cannot run scripts that take 30 MBs of memory, because imagine CloudStack trying to SSH to the VR and let's say run 5 different scripts. That's 150 megabytes of memory. Now, when in a very large environment, when this does happen, we see swapping and a lot of other issues do come up. So the idea is, can we have a small VR agent that has a light footprint, and it kind of manages all the services and whatnot. It supports live patching. Instead of hosting systemvm.iso file attaching on the VR, it is on the management server at some location. The management server can poll using a background task every few minutes or so. Is there a change in the file? If yes, it can automatically connect to that single TLS connection or socket and basically wire all the new changes using something like rsync or BitTorrent or something, or using the existing connection socket which management server can track. And that way we introduce a standard way that how management server talks to a VR directly to the agent. There's no need to actually go through the host. In case of VMware, we do this right now. VMware doesn't support a concept of link local IP, so you don't SSH into the ESXi host to go into the VR. You directly go through the private IP address. Why? Because you're in a management network, so we kind of assume there must be some sort of security and isolation. On top of that, what we are saying is, let's use the CA framework so the connection is secure enough. And we are saying there's a single connection. So if you still want to program 10,000 IP table rules, you're not SSHing 10,000 times. There's only one single fat pipe TLS, TCP TLS connection which you use to kind of program and talk to the VR agent. When you do that, the VR agent is much more in control. Now it can manage concurrency, sequence, synchronization, because one of the issues in VR, a lot of the developers know is when you SSH try to run IP tables by 3 different scripts, the same script but 3 different executions, they can have a lot of issues around sequence and synchronization and whatnot. And we have had a couple of issues at scale. We have seen those things. For example, when you upgrade a CloudStack environment, let's say you have an isolated network, but for some reason it has 10,000 VMs, guest VMs. That means CloudStack will try to add 10,000 DHCP and DNS rules to DNS mask, and in its current form, it kind of restart the DNS mask every time it does that. Now, there are ways to not do that. You can use some sort of, let's say, you can pass a signal to simply say, just reload yourself. Instead of doing a restart, you can reload the service and assume that it will program all those 10,000 rules. When you do restart, even for, let's say, a couple of milliseconds at large scale with 10,000 VMs, some of the VMs may not get IP address, leases, renewal may fail. So you had seen those issues. So if there is a single VR agent which is, handling a single socket per management server, programming could be much faster, and it can manage threading, synchronization, and concurrency. So that's sort of the idea. And the other thing is the non-core services, things like your Apache web server, things like HA proxy, maybe your password server, they can actually run inside of the VR as containers. So that means they have some sort of isolation from the core code. That means your kernel, IP route, IP tables, or NFT now. And those kind of implement the core services in Virtual Router. That means when you have live patch, you containerize a couple of non-core daemons and services. Then as part of upgrade, it should be possible to have almost zero downtime without actually getting rid of the VR. Now for this, I think I don't have time to show some demos, but what I did was just playing with the idea. Can we have a small VR agent with CA framework, TLS secured connection, and I came up with a GRPC based VR agent. So idea about GRPC is you define a protocol buff file. So it's a standard interface file that the compiler can generate the Java library or code in Go specific. So in this example, this was a Go specific agent. The reason I liked Go for this use case was you have a static file, single file, that consumes very less memory, let's say about less than 1 MB in size, and gives you ease as developers. To developers, it is kind of ease. It provides ease, and it's easy to implement new features, handle concurrency and whatnot. And how do we manage upgrade path for non-core services and containers? For this, what we experimented, Abhishek and I, we experimented as part of the CloudStack container service is you can actually create custom Docker images, export them in tar, and those tar could either be sent to the VR through the systemvm.iso file or through the live patch API. So you don't need to restart VR. It's like apt-get update, but without the apt, you're using container images. And of course, if you want to upgrade kernel, there's a new feature. You can live patch the kernel itself. Now, just an example like why I like Go, because you can actually compile Go and you can use Go as a script. So the comment thing, if you put it in a Go file and write a small Go program and you say / that script, like you're executing Python or shell script, it kind of runs. So Go can give you the dynamic programming. You don't need to compile at runtime. You just send Go files. There's a Go compiler runtime in the VR, and it can run scripts like this. Or you have a binary, so it's a choice. We can have something like shell script or Python, but with Go. Now, getting rid of systemvm template, I did a small test. I thought, let's move to Alpine Linux, get rid of all the non-core services. I could reduce the footprint of the disk image size to as low as 50 MB or about 100 MB in size. When you go that low, you don't need to host the files at a hosting service. You can actually package the systemvm template as debs and RPMs, And that could be one way. The other thing is, one of my colleagues, Darren, has worked on a system template management API. So that allows you to upload a new system template. There's an API to register a template. So you can do a lot of things. System template management, all those features you can actually do without just relying on that upgrade path. The last, maybe a bold idea could be, let's not have hypervisor specific templates at all. Let's do a custom live distribution that runs as a read-only root file system, and then we attach the data disk for logs and configuration. So that way, CloudStack can only ship an ISO file which runs as a live Linux distribution, that's the router distribution, and for any config or persistence it uses a data disk. So that way we don't have to build, test and run hypervisor specific templates that we do right now. Let's also think about, can we actually get rid of all those things? That would be great. So can we get rid of CPVM? I think that's something we discussed yesterday. I think yes, if we can package the console proxy as a jar or RPM and let admins decide where they specifically want to host and run, you can run the CPVM on the management server itself. About SSVM, I think the same. You can have a SSVM specific deb or RPM package that can run on a separate host than, let's say, an SSVM itself. How about the VR? So the problem is, except for VMware, it is technically possible to run a bridge-based sort of router, an L3 device on the host itself that acts as a router. And I'm aware of at least forgot the name of the company, but I know of one friend from the community who has done this, and they have experimented where they are not running VRs at all. They have all the core services on a L3 bridge, and they program all the NAT and IP table rules and everything on the host itself. And they don't need core non-core services like DHCP, DNS, and all that. So that seems to be possible. Though there are challenges with the with I think a lot of these ideas, like you have to get rid of the core concept of linked local IPs. That means part of the upgrade process, we will have to work with the community and see if there is anyone has a problem with upgrading and adding some IP ranges on their management IP range. Because if we get rid of the linked local IPs, that means all the VRs which are not taking any private IP will take an IP from the private IP pool. And in general, a lot of this will require code-based changes. And again, not all ideas are good ideas. So again, let's discuss and see what makes sense. I think I'm out of time, so I'll quickly go through some slides. These are different network types that CloudStack supports. My colleague and friend Paul here has given a nice talk on complex networks. There's a link to that I'll share. You can find on the slides, where we want to introduce something called as an enterprise VR, which is an ISP provided router. Like purchase a router, you get a NIC. It's like a wire with a plug. You plug it in. We want that same kind of functionality in CloudStack. And I'll briefly talk about what this ETVR can provide. Like you can have, it may or may not have a port forwarding firewall, VPN and whatnot. It can have chaining. For example, you can bring in your own router. You don't want CloudStack VR to provide VPN. You want to bring in your own appliance to do VPN or SSL offloading or something like that. So it's just a mocked up diagram where you can sort of chain different network devices. So maybe those things can work. The last thing is, as just a consumer of network, I don't want to, it's hard to create networks in CloudStack right now. You have to go through the service offering and say what kind of combination of the VR you want. Maybe having a network designer, a UI designer where you can drag things around. It's like drawing a line between two VMs is like adding them with a wire. So it will automatically plug a NIC. You have an L2 network there, then in there. So those things may be possible. And I think we can take inspiration from other portals, including OpenStack Curvature. It's a project from Cisco, on how they have done this. To do all of this, I guess there are some high-level proposals. We need to refactor and amalgamate the idea for zones. So just zones. Doesn't matter what kind of, it's just zones and then there are networks. There are only two types of networks from a designing or admin point of view, L2 and L3. And what you provide on top of that are those additional features and services. So we need to refactor in a lot of code base, clean up technical debt, which kind of has a lot of assumptions whether the network is a VPC network, an isolated network, whether it is redundant or not. So there are 4 different code paths in CloudStack right now to implement a small feature as simple as program this IP address and DNS record for this guest VM. This is actually implemented by these 4 different tracks, whether depending on whether whether network is isolated, VPC, shared, whether it is redundant or non-redundant. And again, there's some ideas on merging the concept of VPC and isolated, because isolated network is basically a one-tier VPC with some lesser features. And shared network is basically an L2 network with an appliance that provides you DHCP and DNS. So these are some proposals and ideas. Let's discuss maybe during the hackathon tomorrow. And again, if you have any questions, guys? Yes, go on, Jan.
You were talking about to spin up a new virtual router based on an ISO and the time lag that the old one is going down and the new is coming up. Have you considered how to hot standby?
Sorry, consider
a copy of the running
router, right?
Giving all the data from the master
to
a hot slave.
Right.
Kill the master and see how long times it goes before the slave is in action.
Right. I think that's a good feedback. So we currently do support passing the baton from the old to the new in case of redundant virtual router. For that, we use Keep Alive D, and which is VRRP based. Though I think good feedback I think I'll take from that is make every VR redundant capable. So like even if you don't have like an active or a backup, so if for every active VR, we kind of consider every isolated VR to be an active, and when the new one comes up, treat it as a backup and do sort of hot transfer of connections through like contract D and whatnot.
It would have to lead up the data structure, and I think this might be the most important issue here, that is to have a well-documented data structure for any transition from the old to the new.
Right. I think that's a very hard problem, to be honest. I mean, VRRP, Keep Alive D tries to solve that, and it's really hard when you have different versions of the software trying to transfer the state. But I think that's a good feedback. Thank you, Marcus. You had a question.
Yeah, I was just going to say that it's important to keep in mind that CloudStack is built around offerings and providers.
Yes.
And so even though we're talking about kind of the default implementation in CloudStack, there's the ability to do like a virtual router based on a Cisco virtual appliance, or
right?
Vyos or something like that. And we could develop things in parallel. For example, if we have like an open virtual router appliance, then maybe we don't have to worry about implementing all the Python scripts or the Go scripts to actually do programming.
Right.
Might be worth looking at providing another option.
Right.
Default implementation.
Right. That's good feedback. Yes, David.
So in your travels on this one, so I've just learned about how the virtual routers get configured, where the JSON gets shipped out, but then actually configured. Has anybody ever considered using Ansible just to configure these routers? Just declare the state of them and say go. And you don't need an agent.
Right. Right. I think it has come up with someone. I had a discussion on this in the past. But the thing with Ansible is there is an existing code base. So anything new you are trying to do, that's going to take bandwidth and time. So, and it has pros and cons. Like there's a whole debate going on between Python 2 and 3. So that's the first thing I can imagine. The other thing is we want CloudStack to be the source of truth. So
what?
This CloudStack, and I mean CloudStack is the control plane, so that is the source of truth. So all the rules should go from there, and the mechanism you choose, I mean that's fine if you use Ansible or something else. Yeah. All right, guys. Any other questions? All right. So let's discuss in the hackathon, and maybe outside if you have any questions or anything to discuss with me. All right. Thank you, guys.